Hello and welcome to my presentation on Dyadic Design. My name is Shafat Sharia Hussain and today I'm going to present on this topic. So without further ado, let's get into the main crust of the analysis. So first let's discuss what Dyadic Design is. So Dyadic Design is a multi-level design where repeated measures nested within a person is nested within a dyad. So if we try to understand on a general understanding what we had so far, Dyadic design is basically a three-level multi-level model where the repeated measures are the first level of, and the person where the repeated measures are nested within is the second level, and the person is then nested within a dyad. So if we compare the dyad with the regular regression analysis that we have done so far, the dyadic design is different because in normal regression analysis, each observation is been sampled independently. But in a dyadic design, the members of a dyad, that is the person that is that is nested within a dyad, is not independent. They are dependent on each other. So this interdependence between the members of a dyad brings certain complications, and for that we need different statistical analysis to analyze this data. We can solve we can do statistical analysis like ACM with this, but multi-level modeling can also be used to analyze this sort of data. So first, let's get into the assumptions of dyadic data. So the dyads in dyadic data, so basically the persons that is nested within a dyad is sampled independently. Sorry, the dyads in dyadic data is sampled, which is that each dyad is sampled independently. The repeated measures of the members of a dyad is non-independent. So there is the members inside the dyad is not independent; they are dependent with each other. There are three types of dyadic models, which is actor-partner independence model, mutual influence model, and common factor model. For actor-partner independent model, the outcome variable is hypothesized to come about because of the predictor variables. So that is one way to analyze. And then mutual influence model, the difference is that the outcome variables may come about because the outcome variables simultaneously affect each other. So that is the main difference between actor-partner independence model and the mutual influence model. And the third common factor model is that both members of the dyad are affected by a common factor. So there are three ways to look at the dyadic design, and there are three types of models. In this analysis, we will show you an actor-partner independence model. Usually, the type of model you use is based on the research question that you have and the type of data that you have. So, in this presentation, what we have is a data set which is perfectly suitable for actor-partner independence model. To understand that, first you need to know about the data. So, let's explain a high-level overview of the data set. So, the data set is full of dyads, and the dyad is actually each dyad consists of a couple, which is a husband and wife. What we are trying to analyze is that whether the relationship dissatisfaction between a husband and wife is related with the work stress that they have in their workplaces. So whether there is an association between their dissatisfaction towards each other with their work stress. And the dataset has the list of variables, which is couple ID, person ID, and a time variable by which the repeated measures of their dissatisfaction and work stress were recorded. And here, gender is the distinguisher feature of the dyad members. So sometimes in a dyad, the members may not be distinguishable, but in this case, we have a distinguishing feature. The female indicator and the male indicator are basically two dummy variables. So, which is we created during our analysis. This is not part of the main data set. And then our outcome variable is the relationship dissatisfaction from on a scale of 1 to 10. And there is our predictor variable, which is the work stressor variable. The last three variables, which is centered work stressor, trait component of work stressor, and state component of work stressor, these are already calculated. These are actually calculated values of work stressor. So these three are basically decomposing the work stressor into three variables, which will, where the trait component of work stressor will explain the between variation, and state component and the state component of work stressor will express the within component variation of stress between the partners and dyads. So this is what our data set looks like. We have the time variable and the time centered variable, dummy variables, and the gender variables, and also the relationship dissatisfaction and the components that were divided into. So what is our research question? The research question is the number of daily work stressor associated with the end of day relationship satisfaction, extent of association of the typical male and for the typical female partner, heterogeneity in the strength of association across male partners in couples and across female partners in couples. Also, our another research question is, are dyad members' relationship satisfaction on any given day is related? So basically, we are analyzing by male, female, and by dyad whether relationship dissatisfaction has whether the work stress has any effect on the relationship dissatisfaction. So this is some exploratory data analysis. We can see that our outcome variable is normally distributed for both male and female. So and which is actually good. And then there is an exploratory data analysis for 9 dyads basically. So these are the graphs for the 9 dyads where we are seeing whether the work stress within variation having any effect on the relationship dissatisfaction. We can see that for dyad 1, 4, 7, 8, 9, 6, 5, for all these, basically their relationship dissatisfaction is on the same scale. For dyad 2 and 3, the male have a higher relationship dissatisfaction overall, and also in 3 were like slightly higher. So these are the things that we can learn from this exploratory data analysis. And also we can see that on a particular day, like for here, for this timeline, for this number, the third dyad, you can see that there is a similar pattern between both male and female. Like on the same work stressor, and their relationship dissatisfaction jumps. Like it is very harmonic with both male and female. In others, not so much. So these things that we can learn an idea from our data set. So this is the equations of our model. So the first thing to notice about the model is there is no interceptor, and we used straight up a dummy variable across the table. So basically what we are doing is we are suppressing the model to give us only what is happening for the male and what is happening for female, and also combining for the both. So as we use the dummy variable also, you can see that beta naught I and beta 2 I have two random effects, u naught I and u2 I. So basically we are letting these uh, parameters to vary across different dyads. So we will construct this model for both male and for both female, and then combine both of these models together also. So this is the output for our males. We can see that the average relationship dissatisfaction is 5.08 is significant, and also the interaction between male and work stressor is also significant. Randomly, we have not much correlation here, and also 4.65 is significant, and 0.16 is also significant here. There is a slight correlation between them, between in case of female, and then after combining the model, the fixed effect values are basically the same. You can see that it's 0.16 work stress female. These are the same values basically. Also, this is the random effects table where the how the relationship dissatisfaction is varying across different dyads and also within dyads. So what's the conclusion? So from the summary output of model for males, the average relationship dissatisfaction for males was 5.08. There were significant state effects such that on days when a man had one more work stressor than usual, his relationship dissatisfaction increases by 1.11. And from the summary output for model for females, the average relationship dissatisfaction for females was 4.65. Significant state effects such that on days when a woman had one more work stressor than usual, her relationship dissatisfaction increased by 0.16. So there is some relation with relationship dissatisfaction and work stressor. The results of the dyadic model are similar to when the models for males and females were run separately. On an average day, males and females relationship dissatisfaction is 5.08, 4.65, respectively on a 0 to 10 scale. On days when there is an additional work stressor, relationship dissatisfaction 0.11 and 0.6 for males and females respectively. So this is a combined model. And now the deviation around males and females average relationship dissatisfaction is 0.12 and 0.96 respectively. Additionally, males and females relationship dissatisfaction were correlated 0.27, indicated that members of the same diet often have relatively similar reports of relationship dissatisfaction. This we can confirm also from our exploratory data analysis, albeit the sample was really small, like of 9 people, but we saw that most of the as the male and female have same relationship dissatisfaction. The deviation around males and females reactivity to work stressor is 0.15 and 0.44 respectively. The way in which that members' relationship dissatisfaction changes in response to work stressor is quite similar as indicated by the 0.51 correlation. So we can see that there is some sort of correlation here. And also and in each dyad, the males and females, they have similar relationship dissatisfaction. So this is what our reference are: actor partner independence model and the chapter from there, and also another paper on application of dyadic data analysis in behavioral medicine research, meta-suggestion anxiety in fertile couples. So that is our presentation. Thank you.